Namaskar. Uh, Welcome in this lecture series on software engineering fundamentals. This is Dr. Bright Keswani, professor in Suresh Gyan Vihar University. In today's lecture, we will discuss about project planning and estimation models. These are some learning objectives and learning outcomes of this lecture. Through this lecture, you will learn all insights of software project planning and cost estimation models in detail. After the completion of this lecture, you will be able to understand the importance of software project planning and cost estimation models and why these all are required. These are some points to be discussed in this lecture. Uh, First of all, we will discuss about the software project planning, what it is actually. Then we will discuss about software cost estimation, and then we will discuss about various cost estimation modules. Not only cost estimation, uh, but we will discuss about the schedule estimation also. There are some techniques for project scheduling and uh, project staffing. So we will discuss all such type of scheduling in the next few slides. Uh, Let us discuss the first point, which is software project planning. A software project is the complete methodology of programming advancement from requirement gathering to testing and support completed by the execution procedures in a specified period to achieve intended software product. So we can say the software project is the complete methodology of programming advancements from the requirement gathering till the delivery of the product to the client. What is the need of software project management? Software development is a sort of all new streams in word business, and there is next to no involvement in structured programming items. Most programming items are customized to accommodate customers' necessities. The most significant is that the underlying technological changes and advancements so generally and rapidly that experience of one element may not be connected to the other one. All such businesses and ecological imperatives brings risk in software development. Hence, it is fundamental to manage software project efficiently, and this is the need of software project management. Let us discuss about software project manager. Who is software project manager? Software project manager is responsible for planning and execute and scheduling project development. They manage the work to ensure that it is completed to the required standards. They monitor the progress to check that the event is on time and within budget. The project planning must incorporate the major issues like size and cost estimation, scheduling, project monitoring, staff selection, evaluation, and risk management. So these all are the uh, role and responsibilities of project manager. So he ensures the timely delivery to the client. He monitors the progress of the project during the uh, development phases, and he is responsible for the uh, development of product within the budget. To plan a successful software project, we must understand about the scope of work to be completed, about the risk analysis, the resources mandatory for the project, and the project to be accomplished. Then record of being followed or not. Okay, so a plan is very much needed when we are going to handle a big project, a complex project. Software project planning starts before technical work start. The various phases, various steps of planning activities are these are the various phases like size estimation, cost estimation, development time, then resources requirement, then project scheduling. So, what is make the project scheduling? What is important? Size estimation is more important. At the initial level, we have to decide the size of our project because the cost, time, and resources all are dependent on the size of the project. So, what is important? Scheduling is important, but it is based on the size estimation. So, when you calculate the size of the product accurately, you can easily uh, calculate or estimate the cost and time and required resources also. The size is the crucial parameter for the estimation of other activities. Resources requirements are required based on cost and development time, and project schedule may prove to be very useful for controlling and monitoring the progress of the project. And this is dependent on resources and development time. When we start discussion on software cost estimation, we should discuss about the schedule estimation. Schedule estimation and staff requirement estimation may be the most important activities after cost estimation. Both are related if, if phase-wise cost is available. The goal of scheduling estimation is to determine the total duration of the project and the duration of the different phases. So, how to calculate the uh, schedule is an important thing. There are some relationship between the project duration and the total efforts in person month required for completing the project. If the staff needs to communicate for the completion of a task, then communication time should be counted for communication. Okay, by increasing staff for a project, we may actually increase the time spent in connection. So reduce the staff, don't appoint unnecessary staffing, don't do unnecessary staffing for your project, and we cannot treat the schedule as a variable. Okay, we should treat the schedule as a constant. Then only we will succeed in our software project. Each project will require some time to finish, and this time cannot be reduced by putting more people on the project. It only requires an appropriate planning. So, if you think that you more people will make success your project or will um, speed complete the project speedily, then you are wrong. So, what is required? Appropriate planning is required rather than the staffing, unnecessary staffing. Okay, there is a table uh, uh, provided by Bohem or suggested by Bohem, that is Kokomo table, which depicts the phase-wise distribution of schedule. As per the Bohem, there are four types of software projects. When we talk about small size of project, then it is under 2 KDLOC. When we talk about intermediate type of project, it is under 8 KDLOC. And if we talk about medium project, then it comes under the 32 KDLOC. And lastly, when we talk about a large or big project, then it comes under the 128 KDLOC. So there are, according to Bohem, there are only four types of projects: small, intermediate, medium, and large. And according to Bohem, which provides a phase wise distribution of schedule table in a tabular form, he suggests that there are four phases only. First phase of four phases of the development of the software development. First phase is product design. Second phase is product programming, which includes the detailed design, coding, and unit testing. And last phase is integration. So, according to Bohem, there are only four stages of development of project, and there are four sizes of project. So, when we talk the first uh, uh, phase, standard time divided or deputed or spent to the first activity, that is product design. In the case of a small project, you can spend 19% time of the overall project time, and in the case of intermediate, you can spend also 90% time of on product design. Then in the case of medium and large, you can also uh, spend the 19% time of the overall development in the product design activity. But when we talk about product programming activity or phase, in the case of a small project, you can uh, spend 63% time in the development of programming, product programming. But in the case of intermediate, it is 59%. In the case of medium, it is 55%. And in the case of large, it is 51%. When we talk about integration, that is last phase, integration, there are in the case of a small project, it will be 18%. uh, Intermediate case, in the case of intermediate project, it will be 22%. In the case of medium, it is 26% recommended by Bohem, and in the case of large project, it is recommended, integration is recommended 30% in the case of large projects. So this is the phase wise distribution of schedule as per suggested by the COCOMO table. Once we have the estimates of the efforts and time required for the different phases, a schedule for the project can be prepared, and this schedule will be used later to monitor the progress of the project. So, according to the COCOMO model, you can see easily that 19% of the time in all type of projects can be devoted to the product design phase, but it varies in the product programming from 63 and to 951 when we are talking about towards small to large project. And in the integration phase, we can spend less time in small project, but more time in large project, because as Kokomo suggests, as Bohem suggests in the Kokomo table, that on the integration you can spend, if you are having a small project, you can spend 18% time, because it is the integration is a not a crucial activity in the case of small projects. But in the large project, it has to be, it has to be 30%. Okay, let us discuss about the phase process based estimation. If we talk about process based estimation, it suggested the process is decomposed into a relatively small set of tasks and the efforts required to accomplish each task is estimated. A series of software process activities must be performed for each function, and functions and related software processes activities um, are the part of the overall development activity. Once problem function and process activity is decided, the planner estimate the efforts in the person month that will be required to accomplish each uh, software development activity for each software function. And these data constitute the central matrix of the table, and average labor ratio means cost per unit effort are then applied to the effort estimated for each process activity. Labor rate will vary for each task. Remember this, that labor rate will vary for each task. Senior staff heavily involved in early activities in generally more expensive more expensive than junior staff involved in later design tasks, code generation, and early testing. So, cost and efforts for each function and software process activity are completed as the last step of process based estimation. If the results of the decomposition technique shows a small satisfaction, further investigations and analysis must be conducted to for the successful implementation of phase based estimation. Okay, let us discuss about the software cost estimation, which is a very important part of any software, any kind of software project. For any new software project, it is necessary to know how much it will cost to develop and how much development time will it take. These estimates are needed before development is initiated. But how is this done? It is a big question. Several estimation procedures have been developed and are having some common attributes like project scope must be established in advance. Software matrices are used as a support from which evaluation is made. The project is broken into small pieces uh, which are estimated individually to achieve true cost and schedule estimate. Several options arises: delay estimation, used symbols symbol decomposition technique to generate project cost and schedule estimates, and acquire one or more automated estimation tools. So these are some very important you can say the attributes the cost estimation procedure have developed and having such kind of attributes. Whenever we develop a system project, main question that arises in our mind is how much it will cost to develop and how much time it will take for development. Okay, so as I earlier said that these estimates are necessary and needed before initial investigation or initial start of the development of the project. But main critical problem that arises during software cost estimation is lack of case studies of projects usually created in a well documented manner. The software industry has inconsistently defined and explained matrices or atomic units of measure. Data from real and actual projects are and largely and highly suspect in terms of consistency and compatibility. There are many questions as debates among developers and vendors of software cost estimation modules and tools. What are these questions? The topic of debates are which model of cost estimation should be used, because there are lot of models are available and suggested by the software engineering. whether or not to measure software size in source lines of code or function point, and what constitute a good estimate. So these are the questions for debate. Nowadays, there are several models available of for cost estimation, like COCOMO model is there, checkpoint is there, estimates is there, slim or and knowledge plan is there. Among all of them, COCOMO model is one of the most open and well documented cost estimation model. And at present, most of the real world use the cost model is bottom up rather than top down. So uh, uh, there are the manager of software project defines the and describe target cost of software, and after then, until target cost can be justified, it manipulates parameters and size. So this is the illustration. This is the illustration that will provide you guidelines how to estimate the software cost estimation process. This is the cost estimation standard cost estimation process. The process is described in the diagram is very necessary to analyze and predict cost risk and understand sensitivities and trade-off objectivity. It simply forces manager of software product project to examine and find out risks associated with achieving target cost, and to discuss and explain this gained information with other stakeholders. Attributes that good software cost estimate contains. What are the attributes? It is simply conceived, that is planned and supported by project manager is the first attribute. Architecture team, development team, and test team responsible for performing work and task. Secondly, all the stakeholders generally accept it as ambiguous but realizable, and it is based on a well-defined and efficient cost model of software on a credible basis. It is also based on a similar project experience database that includes and contains similar processes, relevant technologies, relevant environments, relevant quality requirements, and all similar people. So there are so many attributes of a good software cost estimate. Now, uses what is the use of cost estimation? During the planning stage, one needs to choose how many engineers are required for the project and to develop a schedule, which is the use of cost estimation. The technique of cost estimation will provide the information that how many engineers or developers or uh, other helping staff is required in a particular phase. In monitoring, the second use in monitoring the project's progress, one needs to assess whether the project is progressing according to the procedure and takes corrective action if necessary. So, uses there are mainly two uses of cost estimation. Cost estimation simply means a technique that is used to find out the cost estimates. The cost estimate is the financial spend that is done on the efforts to develop and test software in software engineering. Cost estimation models are some mathematical algorithms and parametric equations that are used to estimate the cost of a product or a project. Various techniques or models are available for cost estimation, also known as cost estimation models, like empirical estimation techniques, heuristic techniques, and analytical estimation techniques. So, cost estimation models are widely divided into three categories. Empirical estimation is a technique or model in which empirically derived formulas are used for predicting the data that are uh, that are required and essential part of the software project planning step. And these techniques are usually based on the data that is collected previously from a project, and also based on some guesses prior experiences with the development of several similar type of projects and assumptions. It uses the size of the software to estimate the effort in this technique. An educated uh, guess of project parameters made. Hence, these models are based on common sense. However, as there are many activities involved in empirical estimation technique, this technique is formalized. For example, Delphi technique and expert judgment technique. So, Delphi technique and expert judgment techniques comes under this empirical estimation technique method. When we talk about heuristic technique, heuristic word is derived from a Greek word that means to discover. The heuristic technique is a technique or model that is used for solving problems, learning, or discovery in the practical methods which are used for achieving immediate goals. These techniques are flexible and simple for taking quick decisions through shortcuts, and good enough calculations techniques calculations most probably when working with complex data. But the decisions that are made using this technique are necessary to be optimal. And in this technique, the relationship among different project parameters is expressed using mathematical equations. So heuristic technique are based on some mathematical equations, and the popular heuristic technique is given in the constructive cost estimation model. And this technique is also used to increase or speed up the analysis and investment decisions. So empirical estimation technique is the one part of estimation techniques, cost estimation technique. Second is heuristic technique. The third thing is analytical estimation technique. In the analytical estimation technique, it is a type of technique that is used to measure work. In this technique, firstly, the task is divided or broken down into its basic components, operations, or elements for analyzing. And secondly, if the standard time is available for some other sources, then these sources are applied to each component of work. Thirdly, if there is no such time available, then the work is estimated based on the experience of the work. In this technique, results are deriving by making certain basic assumptions but the project about the project. Hence, the analytical estimation technique has some scientific basis. All street software science is based on an analytical estimation model. So we can say Halstead software science is the analytical estimation model. Let us discuss about cost estimation model. As we earlier said that a model can be static or dynamic. It is a static model. A single variable is taken as a key element for calculating cost and time. In a dynamic model, all variables are interdependent and there is no basic variable. So models are basically divided into two categories: static single variable models and second static multivariable variable models. As far as static single variable models are concerned, when a model makes use of single variable to calculate desired values such as cost, time, efforts, etc., is said to be a single variable model. The most common equation is, you can see it on the slide, C is equal to AL, AL raised to power B. So C is equal to cost, L is equal to size, A and B are constant. The software engineering laboratory established a model called SEL model for estimating its software production. This model is an example of the static single variable model. You can see the model in the picture. Secondly, the static, when we talk about a static multivariable model, though these models are based on method 1, they depend on several variable describing various aspects of the software development environment, and in some models, several uh, variables are needed to describe the software development process, and select equation combined these variables to give the estimate of time and cost, and these models are called multivariable models. So this is the equation given by Watson and Flicks. uh, they developed the model at IBM, provide the this equation, E is equal to 5.2 L raised to power 0.91, and it gives a relationship between the lines of source code and effort. In the same manner, duration of development is given by the uh, uh, next equation, that is D is equal to 4.1 L raised to power 0.36. The productivity index uses 29 variables which are found to be highly correlated productivity, like I is equal to summation 1 to 29 Wx, where W is the weight factor for the uh, I ith variable, and xi is equal to -1, 0, +1. The estimator gives x, one of the values dash -1, 0, or +1, depending on the variable increased, has no effect on increase the productivity. Let us discuss about the COCOMO model. COCOMO model is the very famous model, and it is used to uh, estimate the cost of the project. So model is developed by Boehm in 1981, and model estimates the total efforts in terms of person month of the technical staff, and effort estimate includes development management and supportive tasks. So Boehm proposed COCOMO in 1981. COCOMO is the one of the most generally used software estimation model in the world, and COCOMO predicts the efforts and schedule of a software product based on the size of the software. The necessary steps in the model are: first step, get an initial estimate of the development effort for evaluation of thousands of delivered line of source code. Determine Second step is determine a set of 15 multiplying factors from various attributes of the project. Thirdly, calculate the effort estimate by multiplying the initial estimate with all the multiplying factors, that is, multiply the value in step 1 and step 2. The initial estimate, also called as nominal estimate, is determined by an equation of the form used in the static single variable mode, using as KDLOC as the measure of the size to understand and admire the initial efforts, that is, in person month, and equation used is the type of the type of given in the PPT. EI is equal to A multiplied by KDLOC raised to power B. The value of the constant A and B are dependent on the project type. So let us discuss about project type. In Kokomo, projects are divided into two categories, three types: organic, semi-detached, and embedded. A project is organic when project area in which the organization has considerable experience and requirements are less. Such systems usually develop developed by a small team. So, like simple business system is the type of organic. The second one is embedded. Embedded means the organization has little experience. Function is highly affected from the environment. That is software, people, and hardware. In the third category, that is semi-detached, means this is the combination of both programs, both systems, developing a new system or new OS and a simple business management system. So this is your task. So there are three types of software projects available: organics, embedded, and detached, semi-detached. There are 15 different attributes which are used to measure cost, all cost-driven attributes. All these factors depends on product, computer, personal, or technology attributes. So when we talk about um, attributes, there are several attributes of this model. So uh, the all 15 uh, cost-driven attributes, all factors are divided into uh, four parts. That is um, product, computer, personal, and technology. These are the four parts where the um, Kokomo table suggests to proceed. You can see it. There are cost drivers. These are the cost drivers. Various cost drivers are here, and their rating is also there. As per the study, as per the Kokomo suggest, uh, we will provide the facility to the client. So most multiplier for different effort multiplier for different cost driver is this formula. Means EI is equal to A multiplied by size raised to power B. So in the when we the initial estimate is determined by an equation using KDLOC as the measurement of size. So uh, here I is equal to initial efforts in person month, AB is equal to constant or values depend on the type of project, and uh, so let us discuss about the values of A and B for different project types. There are, as I earlier said, that there are only three types of projects: organic, semi-detached, and embedded. For the organic project, the value of A is 3.2 and value of B is 1.05. In the semi-detached project, it the value of A is 3.0, the value of B is 1.12, and C is 2.8. Whereas the embedded projects will uh, have the category of 1.20. So uh, the multiplying factor for all 15 cost drivers are multiplied to get the effort adjustment factor EAF. So the final estimate E is equal to based on multiplying the initial estimate by the EAF. So what is E? E is equal to EAF multiplied by EI. Means F, final effort is equal to effort adjustment factor multiplied by initial efforts. Okay. As I earlier said, there is a size table, and you can predict the value. You can put the value of E, EAF, and EI in the given formula. Then you will easily find out the all the phases of SDLC. The next one is average staff size. How we can staffing the proper staff. How we recruit the proper staff is a big question. Once the project schedule is determined and the staff and schedule of different phases and tasks are known, staff requirement can be determined. From the cost and overall duration of the project, the over average staff size and for the project can be determined by deriving the total effort per person month by the overall project duration. Okay, so staff requirements for a project is a small during requirement and a small and minimum maximum long implementation and testing, and drop down again the software phases of integration and modeling and testing is having more stress. Let us discuss about the rally curve. Yes, this is the rally curve, a sort of curve which is a huge wave is there. The first thing is requirement analysis. This is the requirement analysis and design. This is the peak. Peak means implementation and testing. So implementation and testing is done here. And lastly, final integration and final testing is here. So we can have three things. First is requirement analysis and design. Second is important and testing, implementation and testing. And third is final integration and final testing. So as you know that in the requirement analysis we don't have many people, but at the time of integration and testing we have several people with us, and they are claiming that the house is the they are claiming that the mm, uh, integration and testing through this allocation or this curve will be justified is justified. So uh, this is all about relic curve. Then effect of schedule change on cost. There are several equations are there. So when summarized in starting a new software project, it is important to know how much will it cost in developing, and how much development time will it take needed before development is stated and conveyed to them. The software industry has inconsistently defined and explained matrices and or atomic units of measurement. Measures data from real and actual projects are largely and highly suspect in terms of consistency and comparability. There are many equations and doubts among developers and vendors of software cost estimation model and tools. So As I earlier discussed these software tools and methods with you, that is so it has no other no relevance now. So let us discuss about the last point of this lecture, that is validation of software measures and prediction basis prediction model. So verification of software measures in another way important topic in the area of software measures between measures महत्वपूर्ण measures because the acceptance of software measures in practice depends on whether the measures can be used for a predictor for a quality software quality attribute violation of software measures and predictions models are based on some questions. The first question is it possible to project the error proneness of a system using software measures from its design phase? And secondly, it is possible to extract uh, quantitative features from the representative of software design to enable us to project that degree of maintainability of a software system. And thirdly, are there any quantifiable key features of the program code of a module that would enable us to provide the degree of difficulty of testing for that module and the number of residual errors in the module after a particular level of testing has occurred, so and so on. So there are a lot of questions based on the uh, validation of software measures. So this is all from my side. Now this is the time for assessment. The first question is which of the following are parameters involved in computing the total cost of a software software development project. So there are multiple options. There are hardware and design cost is included, effort cost is included, travel and traveling and training cost is included. So the answer is D, all of the mentioned. In the second question, which of the following costs is not part of the total effort cost? So, cost of the networking and accommodation is one thing. Cost of providing heating and lighting of a space is a different thing. Cost of lunchtime food is yes, it is the right answer. The fourth option is cost of support staff. So the right answer is C, cost of lunchtime food. Uh, in the next question, what is related to the overall functionality of the delivered software? So the questions are function related matrices, product related matrices, size related matrices, or none of the mentioned. So the right answer is function oriented matrices. Which of the following uses empirically derived formula to predict effort as a function of LOC or FP? So there are many functions, but the right answer is B, process-based estimation. The COCOMO stands for. COCOMO stands for what? COCOMO stands for constructive cost model. So the right answer is A. Which version of COCOMO states that once requirements have been stabilized, the basis software architecture has been established? The right answer is early design stage model is the right answer for you. The next question, which one is not a size measure for software product? LOC, Halstead, program length, function point, or cyclomatic cyclomatic complexity? The answer is D, cyclomatic complexity. Estimation of size for a project is dependent on cost, time, schedule, or none of the above. None of the above. Then COCOMO second was developed at University of Texas, University of Southern California, MIT, or IIT Kanpur? The right answer is B, University of Southern California. Which one, the last question, which one is not a stage of COCOMO second? Early development estimation model, application uh, composition estimation model, comprehensive cost estimation model, or post architecture equation model. So these are some questions. The answer of 10th question is A, early design estimation model. So we have discussed many things today. We have discussed how to establish the uh, schedule, how to implement the schedule, so that a small project, even a large project, will work in a proper manner. These are some reference books. If you have any query, then please consult them. Thank you very much.